In this video, I'm going to talk to you about solutions. A solution is some type of solute dissolved into a solvent. For example, you might have salt dissolved in water or sugar dissolved in your tea. The salt or the sugar would be the solute and the water would be the solvent. Water is the most common solvent, although you can have other things as solvents. One way to define this or to think about this is the solute is the thing you have less of, and the solvent is the thing you have more of. So it's a mixture of these two substances. And this particular definition helps if you have a mixture of, say, oxygen and nitrogen gases. Well, which one is a solute and which one is a solvent? It could go either way. Whichever one you have more of is going to be your solvent. And a way to remember this is there's more letters in the word solvent than there are in the word solute. Also, when talking about solutions, we think about concentrations. How concentrated or dilute is our solution? If you have a lot of solute in your solvent, then it's concentrated or strong. If you think about dissolving Kool-Aid into water, if you put lots of the powder, it's going to be concentrated or a strong Kool-Aid drink. And if you don't have much at all, it's dilute. And that's going to be a weak or low concentration of your solute. If you take your Kool-Aid and you only add a little bit of powder, my mom used to do this to make it go farther, and I never knew how good Kool-Aid was until I had it made right later on in life. So we want a way to describe this concentration or the strength of a solution, and we have a unit called molarity which we use to do this. And molarity, the moles of solute in a volume of solution or solvent. So as you've probably guessed, if you're given grams, you're going to have to change it to moles before using this equation. And our equation is molarity, which has the symbol capital M. Don't use lowercase m, that's meters. Molarity equals moles of your solute divided by volume in liters of your solution. So if you're given milliliters, make sure you change it to liters before using this equation. There are basically two kinds of equations or two kinds of problems that you can solve dealing with molarity. The first is either finding the molarity, the moles, or convert that to grams, or volume of a solution. So we have three variables here. You'll be given two and have to find the third. That's one type of problem that you may have to solve. So let's work an example and see how that works. So here's our first problem. If you dissolve 13.5 grams of NaCl, table salt, in enough water to make 200 milliliters of solution, what is the molarity of the solution? Why did I word it this way? I could have said dissolve 13.5 grams of NaCl in 200 milliliters of solution. But if you have 200 milliliters of water and you add 13.5 grams of salt, the level of the water is going to rise and you no longer have 200 milliliters, you have more than 200. So that's why it's written this way. And when you actually make a solution and you want to make it to the proper molarity, you put some of the water in, you dissolve your solute, and then you add water to the correct volume at the end and mix it. So in this problem, we have grams of NaCl and milliliters of solution. And to use our equation, we need moles and we need our volume to be in liters. So we're gonna have to do two conversions before we can pop it into our equation. So we have 13.5 grams of NaCl and we have 200 milliliters of water or of solution. So we need to have a conversion factor to change grams to milliliters, and we need a conversion factor to change, grams to moles and milliliters to liters. So grams to moles, we use our periodic table, and we're going to put 1 mole on top, and on the bottom we have to add up 1 Na and 1 Cl. Na is 22.99 grams per mole, and Cl is 35.45, 58.44 grams per mole. Our grams cancels and we're left with moles. So we are going to have 13.5 divided by 58.44, and this will give us our moles of NaCl, 0.231 moles. For milliliters to liters, there's 1,000 milliliters in 1 liter, so milliliters cancels and we get 0.2 liters. So our equation, molarity equals moles over volume in liters. So our molarity equals 0.231 divided by 0.2, which equals 1.1. So we're going to say 1.16 molar NaCl. If we were asked for moles or grams, our X would be on top and we'd fill in these two numbers. If we're asked for liters or volume, our X would be on the bottom and we'd fill in these two numbers and solve. So if you're asked for molarity, volume, moles, or grams, because you can solve for moles using this equation and then convert it to grams, that's how you would work this type of problem. In our second problem, we're going to look at what if you're asked how to make a solution. So here's our question. How would you make a 1.35 molar solution of NaCl if you need 140 milliliters? Again, we're going to start by using our molarity equation. So we know we want the molarity to be 1.35 molar. We don't know how much solute to dissolve, but we know we want 0.14 liters. Convert that milliliters to liters by dividing by 1,000. So we can find, by multiplying both sides by 0.14, we know that our X, our moles of solute, is 0.189 moles of NaCl. So we want to convert that into grams. So we put 1 mole on the bottom because we want the unit to cancel, and on top we put our grams from our periodic table. We figured that out in the last problem to be 58.44 grams per mole. So we're going to take our moles times our grams, moles cancels. This is equal to 11.0 grams of NaCl. The way that we would write the answer, it's asking how would you make, so your answer would be dissolve 11.0 grams of NaCl in enough water to make 140 milliliters of solution. I hope this has helped. Come back to check my videos for other topics if you need extra help or want to see some examples worked out. Have a great day.